All right, class, this video will show you how to do one-way ANOVA using SPSS, since it is also one of the types of questions given to you in your final benchmark project. First thing is, how are we going to enter the data? And you'll use the example that I posted in the post. So the scenario is that there are 3 different groups of participants, each getting a different dosage of medication, and then we're going to measure the anxiety levels. And since we're comparing the mean anxiety level of more than 2 groups, that's why we're doing ANOVA instead of a t-test. We only have one independent variable, and that is the dosage of medication. And that's why we're doing one-way ANOVA instead of two-way ANOVA. So first thing is to enter the data. Well, we've got 3 groups, and we are measuring the quantitative dependent variable of anxiety level. So the first thing, click on Variable View to enter your data, and I'm just going to have one of my variables called Group, which will be the different treatment groups. And then I click my mouse in this second cell to auto-populate, and since it's a nominal variable, I don't need any decimal places there, and I come over here and put Group in the label box, click Values, and the ... Value 1 would just be called Group 1. Add that. Then go back up to Value 2 will represent Group 2. Add that. And Value 3 will represent Group 3. And add that, and then click OK. The only other thing we need to change is down here in the Measure column, and since it's just group names, we are changing that to nominal. And so, or actually we could even put ordinal. That's not going to make that much difference since they are different dosage, but in dosages, in most cases, the different groups will just be at the nominal level. So I'm going to go ahead and leave it at that for this example. All right, next thing is the other variable is our quantitative dependent variable, and that is anxiety level. So I'm just going to call that anxiety. Click my mouse and change the decimals to 0. There are only whole numbers in the 3 data sets, and come down here to scale since it's a quantitative variable. And then I'm ready to enter the data. So go to Data View, tab down here at the bottom, and I have 6 values in each group. So I need 6 number 1s, 6 number 2s, and 6 number 3s. And then in the anxiety column, I just enter the respective anxiety levels for each group. So Group 1, here were the 6 anxiety levels that were provided for that group. Group 2, and then Group 3, all right, and that's it. So now in order to run the SPSS, we come up here and click Analyze. We actually go down here to General Linear Model, Univariate, because there's only one dependent variable. And then our dependent variable is anxiety. That's the quantitative variable. So click on anxiety, move it over to the dependent variable box. Our groups are our fixed factors. So click in the fixed factor box. And because you will want to run 2 keys post hoc to be able to identify where the significant differences are in case we get any significant differences, then I'm going to actually go ahead and click on post hoc, move the group variable over to the right, click on 2 keys, click continue. And I also actually want to see a plot. It'll make it easier to see where the significant differences are. So I'm going to click on plots and move the group variable over to the horizontal axis and add that. You will not have to include the plots in your project solutions, but it's just a nice visual way to see the significant differences. And then I'm going to go ahead and click continue there. I want my means, so I'm going to click on options, and if I click on descriptive statistics, it will give me my means of the 3 different groups. You can also click on effect size, power, and stuff, but you're not going to be asked to do that on this particular project, although it is nice that SPSS would do those calculations of effect size and power for you. So I'm just going to click continue after I click on descriptive statistics and then click OK. And in our output, we see here the 3 different means and standard deviations. So right off the bat, you can kind of tell that group 3 looks like it might be different from the other 2 because it's low at 4.17 versus the other group means that are at 7 or 7.17. But we won't know for sure until we come down here and look at the ANOVA output, which is this box down here. And the row that you are interested in is this 3rd row because the name group was the name of our independent variable. It will put whatever name you've typed in when you were entering your variable names. And so notice we have a F test statistic of 11.808 and a p-value of 0.001, which is a very low p-value, okay? That's going to be the information you want to put in your response. 11.808 is the test statistic. P-value is 0.001, and that, of course, would mean since your p-value is less than 0.05, you reject the null, and you have enough evidence to say that there is at least one group that is significantly different in terms of the anxiety level. And we can probably guess which one that is, but we'll check our post-hoc test to see for sure. So in our post-hoc Tukey results down here, we see that group 1 matched with group 2 in that pairwise comparison has a very high p-value. So those are not significantly different. But when we pair group 1 and group 3 right here, we see that yes, it's a low p-value of 0.002. So group 1 and group 3 are significantly different. And then down here, group 2 and group 3 also significantly different. So the low p-values are basically between group 3 and group 1 and group 3 and group 2. So group 3 is the one that is significantly lower than the other 2. We knew it was lower because we saw our means up here and saw that it was only at 4 point something. Plus we can scroll down and look at our plot and clearly see that group 3 was lower, significantly lower than group 1 and group 2. Group 1 and group 2 were not significantly different. And we could tell that with our Tukey post-hocs because when we paired group 1 and group 2 together, we got high p-values. So pretty easy to generate that output and not too bad at interpreting all of that for your one-way ANOVA question in your project.